Okay, so what we need to do then is just practice identifying main effects and interactions. We're going to see a lot of this not only in the textbook graphs, but also in the graphs from some of the articles that you read. Now, remember, when I test on book related material, what I will look for in part is going to be graphs of studies that you guys need to know. What is the IV? What's the DV? What are their main effects of the interaction? So you guys need to practice with this. All right. So let's go ahead and start. So let's say the easiest way to identify an interaction and main effects is based on the graph. So let's go ahead and draw the graph. So this is going to be the beer goggle effect. Okay. What we have is we have attraction. So this is how attractive you view the pictures, and it's on a scale from remember it's 1 to 5. And remember, this is the beer goggle effect. So what we're going to have here down the bottom is we're going to have the attractive photo and the not attractive photo. And over here, what we're going to have is we're going to have alcohol. I'm just going to put beer, and no alcohol. So I'm going to put no beer. All right. Beer just because I was running out of room on my screen. So let's say we have these things. So remember what we said is if the beer goggle effect is true, then what we should see is a particular set of findings. So let's go ahead and practice. So if you view the attractive photo with the beer, what number should we get? Let's just pick one. Let's just say we're going to go to 4. Now, the non-attractive photo, or the attractive photo with no beer, I mean, the photo is still attractive, so let's give it a 3. I'm going to put the mean score up here because I know my drawings aren't exactly precise. Now, on the other side, we have the non-attractive photo, no beer. Let's do that one first. They should get like a 1. All right. Now, what's going to happen with the non-attractive beer? Well, let's go ahead and give it, I don't know. Let's go ahead and give it a 4. Okay. So let's say our graph looks like that. And once again, I'm sorry for my drawing. It's not precise. I'm trying to use this stylus pen, which is weird. So here's what we do. So first we're going to test main effects. So the main effect of attractiveness, mathematically, the way you calculate it is you take the main effect of attractiveness. Remember, we're comparing now this to this. So what you do is you take the 4 and the 3 and you average them. So 4 plus 3 is 7 divided by 2. That's going to be a mean of 3.5. Over here, we're going to do the same thing for the non-attractive. 4 plus 1 is 5. Divided by 2, that's 2.5. Now, what I should have said at the beginning is let's assume any difference of 1 is statistically significant. So we see here is 3.5 is 1 greater than 2.5. So we do have a main effect of attraction, of attractiveness photo. Then I would ask you, who's higher? Well, you would say that if you view the attractive photo, you scored significantly higher, or you rated the photo significantly more attractive than the non-attractive photo. Check. All right. Now let's do the main effect of alcohol. So what we do now is we look at the alcohol. That's going to be this group here. So you take the clear bars, 4, and you average them. 4 plus 4 is 8 divided by 2 is 4. Okay. For the no beer condition, that's 3 plus 1, because those are the shaded bars. 3 plus 1 is 4, divided by 2 is 2. So is that difference greater than 1? Yes, it is. So we're going to say P is less than 0.05. So we do have a main effect of alcohol. And if I was to say interpret that, you would say that the photos, independent of what photo you viewed, if you viewed a photo while drinking, you rated the photo significantly more attractive than if you are not drinking. All right, and we know that because that's what the difference in the means refers to. So what we have is we have a main effect of attraction. We have a main effect of alcohol. And now the question is, do we have an interaction? Now, the easiest way to tell an interaction is going to be when you graph this, if you look at the lines. So what we're going to do is we're just going to connect the dots here. And if those lines are not parallel, you have an interaction. And you can see here, these lines are not parallel. Now, if you like the math angle to this, another way to do this is to take this number here 4, subtracted from this number here 4, you get 0. Take this number here 3, subtracted from this number here 1. 3 minus 1 is 2. If those numbers are different, 0 and 2, then you have an interaction. So if you like the math approach, that's the way to do it. You just subtract the numbers. If they're the same, there's no interaction. If they're different, there is an interaction. But I like the graphing approach better, to be honest. I'm a very visual person, and so you can see just when you draw those lines, there you have differences. You have significant differences between the slopes of those lines. And when that happens, that means you have an interaction. Now, and if you interpret an interaction, so it is significant. So we would say we have 2 significant main effects. We already interpreted those. And then you say we have a significant interaction. So this is for the interaction. Okay. What then you would have to do is you would have to further delve or probe into that interaction. Now, that's a little beyond the scope of this course, so I'm not going to worry about us doing that. But just know that when you see an interaction, what that means is that you cannot interpret one main effect without talking about the other. So the two go hand in hand. All right? So let's go ahead and keep practicing with this. So let's say, and now you can have all different combinations. For example, you can have 2 main effects, no interaction. You can have an interaction, no main effects. You can have 1 main effect, no, 1 main effect, 1 interaction. There's a lot of different things you could do. So let's go ahead and keep practicing with this. All right, so let's say that any difference of 1 is statistically significant, okay? So let's say we have a graph that looks like this. All right. My suggestion is to pause the YouTube video after I draw this and figure out, do we have any significant main effects or interactions? All right, so pause it and work through that real quick. All right, if you did that, welcome back. What we see here is this is going to be no interaction. The slopes are identical. Okay. And then there's also no main effect. So these means, I draw them up here. If you average this variable here, like this, if you average them, you'll see that this average, this is going to be 0.5. This average will be 0.5. They're identical. No main effect here. Over here, it's going to be also 0.5. 0.5. I'm silly. I'm sorry, everyone. That's silly. I'm at 1. Let's add, Chris. 1 plus 1 is 2. Divided by 2 is 1. So what we're going to see is that the mean score for all groups are 1. So we have no main effects, no interactions. Sorry about the bad math. All right, let's try another one. Let's try this one right here. So we have independent variable, level 1, level 2, level 1, level 2. Now let's draw our thing here. Let's say I have something like this. So it's going to be, let's just draw it up to 3. Make our life make our life easy. So this is 3, this is 2. Let's do something like this. This is 2. This is 1. All right, so quick timeout, pause it. Tell me if we have main effects and interactions. All right, so welcome back. So the way it works is dink, dink. No interaction. Those lines are parallel. If you look at the main effects, what you'll see here is that this is 3 plus 2 is 5 divided by 2. That's 2.5. 2 plus 1 is 3 divided by 2 is 1.5. We have a main effect there. And then over here, 3 plus 2. Sorry. 3 plus 2 is 5 divided by 2. That's 2.5. 2 plus 1 is 3. Divided by 2 is 1.5. So this would be 2 main effects, no interactions. All right, 2 main effects, no interaction. All right, let's try one more. Let's go 4 this time. Let's say we do this. 2, 1, Oh, sorry. Good Lord, what is happening to my pen? Something like that. All right. So once again, I'm going to give you a sec. I'd recommend pausing it and then figuring it out, and then we'll try again. All right. So if you did that, welcome back. So let's test the interaction first. Those lines are not parallel. We have an interaction. Check. Let's do the main effects. 2 plus 1. That's going to be 3 divided by 2 is 1.5. 2 plus 1, same thing. 1.5. No main effect here. Let's test over here. 2 plus 2 is 4. Divided by 2 is 2. 1. I'm sorry. Let's try that again. For this one, it's 2 plus 1. That's going to be 3. That's divided by 2 is 1.5. For the shaded one, that's 1 plus 2 is 3. Divided by 2 is 1.5. So this is what we have is an interaction with no main effects. Now, what I've done for you to help you with this is... we know. Discard. What I've done for you is if you look on Moodle, I have this sheet for you. This is a practice sheet. And once again, these are the 6 things you need to be able to answer. So I like drawing the graph. I like having you practice with that because it's, in my opinion, if you can draw a graph that looks like this, then you can interpret a graph that also looks like that. So these are the 6 examples. What I suggest you do is try it first on your own. So literally get out a sheet of paper and try to do these 6 things. All right. Now, if you scroll below, so let me go down to the next page, you will see my answer. All right. Not only will you see my answer, but you will also see the math, how I came up with that answer. All right. And I have all 6 of them worked out down here. Now, these aren't the only examples of these graphs that you could have. But needless to say, once again, I'm a big believer that if you can draw them, you can interpret them as well. So my suggestion is to practice with this and see if the math works out. If you can do this, you are going to be in great shape. When we do our research club meeting, when we do our Skype session, I'm going to ask you to look at graphs and tell me if there's a main effect or interactions just by looking at these things. Now, I want to caution you is this thing right here. Whoa, this thing right there. Let's highlight it. I always have to tell you that. I always have to tell you what difference is what quote unquote statistically significant. Now I'm doing this for the ease of presentation. There's no magical number 1. It's not like 1 was picked for any statistical or theoretical reason. It's just for ease of math, I picked 1 in this case. So in articles that you read, you could have differences of like 0.3 or 7.9, and those are what makes it significant. So don't treat this number 1 to be anything special than just the fact that, it's a number. That's going to be my suggestion to you guys, okay? So I think that's it for Chapter 2. We got one more unit before the first exam. That's going to be social cognition, and I'm going to upload those things once I get them made.